So that example of a temperature compensated strain sensor, especially one where the FBG is shared, brings up an interesting conversation about when do you average FBGs or when is it better to average sensors. So in Nlyte, there are multiple places where averaging can be performed. And it varies somewhat based upon the interrogation system that you're using. Starting with the SM130 that we're using for our current example, you'll see there's an element here that says spectral response averaging. While this is of significant importance when using a static interrogator, an SM125 or any of the X25 line, it's really, its value for an X30 is only aesthetic. Essentially, this full spectrum trace for an SM130 is used for exactly how we used it, which is to establish gains, thresholds, and ensure that peak tracking is working as expected. There is no measurement data that's extracted from that full spectrum in the case of an SM130. That's different in an SM125. In an SM125, the full spectrum data is actually the source of the data coming from the interrogator, and peak detection is performed in the application in Nlyte. So in the case of an SM125, the spectral response averaging is the first place in which averaging will affect the stability and time response of the measurement. So if acquiring from a 2 Hertz interrogator, you apply 2 averages, effectively the time response of the entire system will be brought down to 1 Hertz, and you'll get a square root of 2 reduction in the noise of the spectrum itself before peak detection. Okay?
One thing I would like to point out there on averaging of the full spectrum is, again, as we mentioned earlier, the full spectrum has 32,000, depending on which interrogator points. If you do set that averaging to a very large number, say 500 or 1,000, your time response is becoming very, very, very slow, and 2, you are consuming a considerable amount of memory. And I've seen times where that was set high enough that it was able to use up all the available RAM on the system and cause issues, to say the least.
So average judiciously. There isn't a control on how many averages can be taken, but you do need to be aware of the impact, as Dan said, on memory usage, as well as the impact on time response of the system. Here you can see that there's an appreciable reduction in noise with just 10 averages on the spectral trace. But again, in the case of the SM130, that's largely aesthetic. In the case of the 125, it is important because the less noise that's on the spectrum of each FBG, the less resulting noise is going to propagate through the peak detection, which will give you a more stable peak value. But also, if you're going to see any sort of dynamic changes, you have to realize that each spectrum is going to be averaged together, so that if you're having a rapidly changing peak, you're going to see basically a roving average of that spectrum. And so you do need to be conscious of the time constants of your sensors along with the averaging.